Okay, let's start today's class. So I'll start today's class first with a brief introduction about myself for those who don't know me as well as the center, for those who don't know the center. So I'm not sure how you all heard about the center, maybe through your friends, maybe through your parents, maybe through online or social media. Whatever it is, today we'll just give you a very brief introduction of the center. So hopefully you guys can join us next year, especially when next year most of you guys are taking your O-levels. Okay, so Overmugged, right, is a tuition center that does secondary and JC tuition. But I think we're definitely into primary next year. So we're kind of a young tutor team because we don't want to have a big generation gap with all of you guys. So at least we can relate with you guys when you have troubles, especially non-academic troubles, okay, that you have. You know, the raging hormones and whatnot, teenagers nowadays. Okay, but anyway, my name is Miss Pamela. So I've been teaching in Overmugged ever since it started, and it was initially like a home-based business. You know, we started off from home, and then after that we moved off to become a center. So I've been teaching so far in Overmugged the A-level students as well as the O-level students, mainly the upper secondary, which is you guys, Set 3 and Set 4. Then after that, next year, if you decided to go next year, decide to go into JC, then we will see each other again. But I mainly just do the physics and chemistry portion. Okay. Then I've been teaching so on for quite a while. Hello, Sec 6. Yes. Do you have the note? Okay. Let's just see. Okay, so I've been teaching for 12, 13 years, every year about 60 to 70 students, not too much, but not too little as well, so that I can manage these students. So one interesting fact about myself, if you don't know me, I'm a massive F1 fan. And anyone here is an F1 fan? No one? Oh, sadly. The guys are hotter than the ones in football, I feel. Yeah, but anyways, that's me. And for those who don't know, I just recently gave birth. For those who know, they will some of my students here. Okay, they recently just gave birth to a cute baby boy. I think it's cute. Maybe other people think it's cute. Okay, but anyways, for Overmugged-wise introduction, we have about so far, I think 7 branches across Singapore. So you're in one of sort of like what we call flagship branches in the east side, Marine Parade. But we recently just opened a new branch in Tampines. So Tampines CPL building there as a new branch. Hello. Do you all have the notes? Okay. It's free sitting, so you can sit anywhere. So we recently opened a new branch in the east side, which is Tampines as well. So if you have time, you can go there. The reason why we want to introduce all the different branches to you, right, is because Overmugged students have the rights to actually go into any of the centers and study. So most of my students nearing the exam period, right, they like to study long hours, especially if your parents are agreeable. They do study up to like 11 p.m., 12 a.m. the kind at Overmugged Center. It's kind of scary. My JC students, sometimes they stay overnight at the center purely because it's closer to their school than their home. So when they have exams, right, they just stay at the center and just go. But obviously, we have CCTVs and whatnot like for safety. Okay, so these are what centers we have across. So if let's say you sign up with us for class, you can just text the teacher, oh, I want to come here and study, then just sit here, turn on the aircon, eat the snacks, do whatever you want here. Academically, not non-academic. You don't come and then there's a rave party going on. Okay. Okay. So all these are stats that y'all can find online. You know, basically, how we are performing as a center. But what is most important is, right, our tutors here are pretty young. We are all some students, some tutors are actually university just recently graduated, or there are some tutors like me who has graduated a long time ago, but I'm not that old yet. Okay, so I'm still quite young. At least there's no generation. There is a generation gap between both of us, but it's okay. I choose to be young. Okay, so we hope if you are interested, when you guys join us, at least you can form a community here. At least find some friends, you know, form a clique, you know, form a group here, study together. Because ultimately your study journey is going to end sooner or later. 10 years later, this probably will not mine already. You know, you'll be working adults and then you'll have different sets of problems. Okay, now what is more important is our resources. So we pride ourselves in our resources. Whatever you receive today, right, is kind of like an introduction to, actually not really an introduction, it's pretty much what we have been giving out our students as well. Okay, so if you realize, right, the revision kit that you guys have here, For those who are physical, right, you have the full revision kit of all the topics that is listed in the content page. For those online, you only have the 3 topics that we'll be going through today. But it is a little tidbit into the resources that we have made for the students in-house by our teachers here. So we don't actually, like copy from whatever school sources or photocopy from assessment books. No, all these are the tips and whatever notes that the teachers here think it's important for your exam. So it's actually a very good set of curated notes. On top of that, we do have science practical exams for our regular lessons. So I'm not sure if any of you guys are very worried about a practical, because some students can do well in theory, but don't really do well in practical, right? So practical takes up about 20% of the overall score. So here we do have practical exams to help you train you guys for practical, at least an additional practice from your schools. If let's say your school only gives you very minimal practices. Okay, then based on the different teachers, we do have cheat sheet as well as after class consultations. So some teachers here are pretty scary. Their after class consultation you go up to like 5 a.m., 6 a.m. that kind. I cannot. 1 a.m. is like my match really. Okay. Okay, so without further ado, we'll look at this later. Let's take a look at what we'll be going through today for our holiday revision session. So like I said, those of you guys who are here physically, you receive the full set of notes from physical quantities all the way to light, as well as the last page here, which is some master compilation of formula and definitions. Oh, now my screen is a bit. Yeah. Okay, but for those online, you will only receive the revision kit for the 3 topics that we'll be going through today. But if let's say you do want the full set of notes, you can come down to any of the center to just collect physically, provided they have stocks. Okay, hello, Sec 3. Okay, good. Now, let's start with today's lesson, first lesson, which is dynamics. Now, for today's lesson, right, wait, just a show of hands. Any of you guys done the mock paper that is supposedly should be done before you come for the class? Just you? Anyone else did? No? Do y'all know that you're supposed to, okay, do y'all know that you're supposed to do a mock paper? Okay, so by right, you're supposed to do the mock paper at the back before you come so that we can revise. But it's okay. We will still go through the questions in the mock paper today. Just that I'll give you guys a little bit of time to actually do the questions before I go through. Okay, so at least you'll attend. Then the rest who have done it, right, just check through your answers. Okay? Okay. Okay, now for the 3 topics that I'll be going through today, right, I'm not going to go into detail all the different concepts that you are supposedly already know, because right now, September, the next month onwards, you'll be having your exam. So, or this month onward, you'll be having your exam. So it's important that you already know all your content. What I'll be going through would be all the tips and essentially some stuff that can help you to study better, especially for these 3 specific topics. Okay, so let's take a look at our first topic first, which is dynamics. Now, I'm not sure how many of you struggle with dynamics, but a lot of students who have done this topic, right, feedback to me that they find it tough because of the fact that they are unable to draw, let's say, a free body diagram, or even when they draw a free body diagram, their free body diagram is wrong. Okay, so we're going to look at this topic here, which essentially, right, talks about the forces that leads to a motion. So prior to this topic, you did kinematics. Kinematics was a study of motion, specifically just studying, okay, what is distance, what is displacement, speed, velocity, and what's acceleration. But behind or even before motion started, what causes motion was actually forces. And dynamics is the study of these forces that resulted in motion. Okay, so in dynamics, you learned about Newton's 3 laws, Newton's first law, Newton's second law, and Newton's third law. Now you can see here, I put do not memorize or do not need to memorize, because your schools, or rather at least O-levels, they will not test you state Newton's first law, state Newton's second law. Okay, if your school do test you, it's just purely to make sure that you actually study. Understand? But O-level wise, they don't actually require you to memorize, but they require you to know the laws and use the laws to explain a certain phenomenon. So most of the time you see questions say explain using Newton's law of motion. Then it's your job to find out, do I use first law, second law, or third law? Understand? So let's go through these 3 laws first to make sure you understand them. When we talk about Newton's first law is directly linked to this part here called inertia. Not a lot of students recognize the fact They just thought that Newton's first law means if my object is at rest, my object remains at rest. If my object is in motion, my object remains at motion, unless acted upon by an external force. But in short, if we were to summarize this entire thing into a single word, Newton's first law meant inertia. So what does this mean? This means that, or what does Newton actually mean when he said this? He meant that if, let's say, there is the presence of a net force, then my object will either accelerate or decelerate, depending on whether my net force is positive or negative. That's what Newton is trying to say. But if, let's say, there is no net force present, okay, then Newton says that your object is either at rest or it is moving at constant speed. So what a lot of students tend to be confused about, right, is that when they say there is no net force, then a lot of students say, oh, that means the object is resting, not moving at all. That's not the case. The object is not moving only if beforehand it wasn't moving. If beforehand it was already moving at constant velocity, if there is no net force, it will continue moving at that constant velocity. Do you understand? Okay, so this is what Newton's first law is trying to tell you, that the presence of a net force affects its motion and inertia. Okay, so then what is inertia? Inertia is the reluctance of a body to change its state of rest or motion. So basically, if your body is already at rest, you want to remain at rest. If it's moving, you want to continue moving. That's the meaning of inertia. I believe all of you guys know that. But what a lot of students tend to be confused about is, okay, so I write inertia, reluctance of a body to change its state of rest or uniform motion. Okay, now, a lot of students tend to confuse that inertia is dependent on speed. That is not the case. Inertia is dependent on mass, not speed. So if it's not the fastest object has the greatest inertia, it's not the case. It is the largest object has the greatest inertia. That's why when an elephant chases after you, the elephant has a harder time to change its state of direction as compared to you, because the elephant is much larger in size. Understand? Not because the elephant is faster. So inertia dependent on mass, this is the next thing that you need to take note of. Okay, now moving on to the next one, Newton's second law. So Newton's first law mentioned what? Newton's first law mentioned that if there is a net force, I will either accelerate or decelerate. If there is no net force, I remain in my state of motion. So then that brings us to Newton's second law, where he elaborated more on the net force. He said that since I say that there is a net force, there is an acceleration, is there an equation that link these two things together? There is. F net equals to ma. So that is what his second law is talking about. Okay, such that the resultant force acting on the body will always be equal to the product of the mass and acceleration of the object. But underlying this equation here, a lot of your school notes, right, actually says F equals to ma. I don't want you to remember that because F is very confusing. I want you to always remember F net equals to ma. Or you don't really like F net, you want to use resultant after you resultant force equals to ma. Okay? Then a lot of questions like to test you, how do we find F net? F net will always be found by taking the applied force. If the question do apply any force on the system or the object, minus away your frictional force. Okay, so once you have done that, you can equate that into ma, then using that you can find your acceleration. So that's Newton's second law. Okay, then next, Newton's third law. Now, what does Newton's third law say? Newton's third law says for every action, there is an equal and opposite reaction. It's pretty much like if you slap your friend will slap you back. Correct? Okay, so every force exerted, there will be a reaction force. But a lot of students cannot get this part correct. What do they mean by action-reaction pair? So let's look through the conditions first. In order to be an action-reaction pair, you need to be equal in magnitude. You need to act on different bodies. You need to be opposite in direction. And the most important, you need to be the same type of force. Okay. Now, why do I say that is very important? Because let's take a look at this scenario here. I have a table, okay, and I have a box resting on the table. Now, there are two forces here that I can see quite explicitly, the weight as well as the normal contact force, correct? Can I ask you guys, is the weight and the normal contact force an action-reaction pair? Who says yes? No? Yes or no? Even if guess, also got one answer. Who says yes? The box is not moving, it's resting on the table. There is weight, there is normal reaction force. Are they both action-reaction pair? No. Why?
Not the same type of force.
Yes, they are not the same type of force. That's what a lot of students tend to be confused about. They just say, correct what? Equal in magnitude, opposite in direction. But do you realize that, right? Number one, it doesn't fulfill the criteria that it is not the same type of force. What do I mean? If you look at this is a weight force. Technically, it's a gravitational force, correct? Due to gravity. But is normal contact force a gravitational force? It's not. It is a surface force. So it's completely different type of force. Second, it doesn't fulfill this, act on different bodies. Why do I say that? The weight here is the weight of the box by who? By Earth. The normal contact here is the normal contact of the box by what? By the table. Can you see both of these forces are acting on the box? They are not acting on different bodies. Clear? So then the question now is, if this is an action force, what is the reaction force? The reaction force will therefore be, this is your Earth. Now, your Earth itself also experiences a weight force that is pulling it due to the box. Understand? So this weight force is the weight of Earth by box. Now, then these two are considered to be action-reaction pair. Same type of force, weight, acting on different bodies. Okay, one is on box, one is on Earth. Number two, number three, equal in magnitude, and lastly, opposite in direction. Yeah. So that is the action-reaction pair for the weight. For the normal contact force, this is normal contact force of the box by the table. So therefore, the reaction force would be down here. No space, but I can draw it here. The normal contact force of the table by the box. Understand? So a lot of times if they ask you to identify an action-reaction pair in the exam, right, it's very straightforward. Whatever wording they use for that force, you just copy exactly the same wording, then just swap your on what by what. On table by box, on box by table, just swap it. If they use a very weird phrasing for that force, it is the upward trajectory force on chair by table, something like that. Then they ask you for the reaction, you copy the exact same thing. Downward trajectory force by table on chair. Just flip the on and flip the direction. That's it. Understand? Okay, so do not be confused by this action-reaction pair. Okay, clear? Okay, good. Now, let's take a look at some questions first that talks about the Newton's three laws. So in dynamics, right, they can come out questions that test you on these three laws, but they won't explicitly tell you that, oh, use Newton's first law, second or third law. They will ask it in the form of a question. So what do I mean by that? Go to your mock paper. Can we take a look at question 3 first? MCQ question 3. Okay, this is a classic dynamics question that requires you to know Newton's second law very well. Maybe I give you guys a while to try question 3 before I go through. Okay, can I go through? Shouldn't take too long for an MCQ question. Now, for this answer here, the answer technically should be B. So if you don't get B, you're not correct. Now, how do we do such a question? These kind of questions commonly tested in your MCQ. But whatever it is, always remember, if you have a system where you have blocks that are put together in a same string, or let's say a spring, or whether is it a mass pulley system, the number one thing to always take note of is that the two objects or how many boxes there are will always move at constant acceleration. Understand? This is the number one criteria that you need to keep constant. It will always move at constant acceleration, or actually not use the word constant, can change to the word same. Secretary, do you have the note?
Yeah.
You have the note, okay. Same acceleration instead of constant acceleration. That means, right, the acceleration of S is equals to the acceleration of R, which is also equals to the acceleration of the whole system. And whole system meaning R plus S. Okay? So once you have questions like that, we usually can draw three free body diagrams. What are the three free body diagrams that we have? Number one, my first free body diagram is whereby I combine both R and S together. So R and S, okay, only experience a resultant or a force at this direction here, 16. That's my first free body diagram. Clear? Next, second free body diagram I can draw is the one for S. So what are the forces acting on S? The forces acting on S are, you have the 16 Newton acting towards the right, and you have a tension force acting towards the left. That's the second free body diagram that I can draw. The third free body diagram is the one only for R. So only for R here, there is only one force acting on R, and that would be the tension force that is acting in this direction. Okay? So these three free body diagrams can help you to solve questions. Thank you. Now, let's take a look at how to look at this. They say 16 Newton force acting on the same mass, on mass of R for 6 kg, mass of S for 2 kg. So that means the total mass here is 8 kg. The total mass here is 2 kg. And the total mass for R here is 6 kg. Okay. Assuming that the fall is frictionless, means there is no friction, you need to draw your free body diagram. What is the tension? T is what I want to find. So usually, what do? I use this relationship first. Same acceleration. Now, your first free body diagram allows you to find the acceleration. Can you see that? Because what is the net force acting in this diagram here? The net force present is only 16. So since F net equals to MA, 16 is equals to 8 times A. So A is equals to 2 meters per second square. So now you have found out the acceleration for every single block. including the one for the whole system. Do you understand? Then from there, I can make use of either diagram 2 or diagram 3 to find the tension. Easier method, diagram 3. You want a slightly more complicated, diagram 2. I'm going to show you guys both methods so you can see that the answer is the same. We take a look at diagram 3 first. Same thing, I use F net equals to MA. What is F net here? Since the only force present is tension, F net is therefore tension. Okay, equals to, what's the mass? 6 kg. What's the acceleration? 2. So total tension 12. Okay. If let's say you want to make your life difficult, you want to choose diagram 2, also can. So diagram 2, same thing. We're going to do F net equals to MA. Now, what causes the F net? This is where you need to be careful. You need to first check for the overall system, where is it moving? Is it towards the left or towards the right? In this case here, since it's moving towards the right, therefore my F net is made up of 16 minus tension. Okay? If it's moving to the left, then your F net should be tension minus 16. Yeah? So then this is equals to, what's the mass here? 2. What's the acceleration? 2. So 16 minus tension is equals to 4. Therefore, tension equals to 12. So you see, you should get the same answer. And it has to make sense because along the same string, your tension needs to be the same on both sides. Because if it's not the same, your string will break. Understand? That's how your pull toilet paper in the toilet. Why is it that the toilet paper will snap? Because you are pulling a force greater than the tension. That's why it's snapped. Understand? So by right, for the same string, the tension force has to be the same if your string did not snap. Yes? Okay. So this is the way to answer this type of question. Always draw the 3 free body diagram. Actually, 2 is enough, but if you can't unbalance inside, right? Then just draw 3. Okay. Okay, now the next question, can we take a look at question 4? So that was Newton's second law type of question. Can we take a look at question 4 now? Just quickly answer this part. If you remember what I say, this one is very easy already. Okay, don't even need to think much. So question 4, what's the answer? Anyone? Sorry? Answer is B. Correct? Because all you got to do is just identify the same type of force. Weight and gravitational force is the same. So then you just change from by skydiver on Earth or skydiver by Earth. Okay? The first one, force pushing a book, frictional force. These are not the same type of force. Part C, weight and tension, they are not the same type of force. Hello, Secretary. The last one, man exerting a force to pull the door. So it's sort of like a pulling force. It's not the same as normal contact force. Understand? Okay, so you just got to identify the same type of force. Okay, good. So now let's take a look at the notes back to the notes now. Okay, now for notes, for the next part under dynamics is the drawing of free body diagram. Now, free body diagram, right? Always tell yourself when you draw a free body diagram, make sure you go through your entire list of forces that you know to draw a free body diagram. Some of the most common forces that they can test you on when you draw a free body diagram are, just go through the entire list next time when you draw. Weight, normal contact force, friction, tension, air resistance, thrust, drag. Okay, at least when you draw a free body diagram and you don't know what forces to draw, just go through this entire list. Most of the time, this is the list that is enough for you for your syllabus so far. Yeah. Okay. So let's take a look at some of the tricky free body diagrams to draw. The normal ones are pretty straightforward. The tricky ones are, let's say I have a person walking. What are what is the forces acting on a person that is walking? You realize that if the person is walking in this direction, the friction is not backwards. Okay, because we all know that friction opposes the direction of motion. But you look at your shoe, in order for you to move forward, you need to step, then drag your feet backward. Correct? So by right, the force that you exert on the floor is in this direction instead. So this is the force that your feet exerts on floor. Okay? That's why, or rather the frictional force that your feet exert on floor. That's why the friction that the floor exerts on your feet is in the forward direction. So this is friction by floor on feet. Yeah. Same for if you have a bicycle. So a bicycle, right, they like to confuse you with the word free moving and engine powered. So most of the time, same for cars as well. Some cars, right, their front wheel are free moving. What does free moving means? Free moving means, right, it's not controlled by any engine. It moves how the car moves. So if the car moves forward, then your wheels will move forward as well. If the rear engines or the rear wheels are powered by the engine, that means the rear wheels are being controlled by a certain power or a thrust that is brought about by your engine. Understand? So if let's say your bicycle is moving forward, for example, okay, then I think they have a missing direction here. So maybe you guys just draw an arrow, right direction of motion, of movement. Okay. So if let's say your bicycle is moving in this forward direction, the wheels that is not controlled by the engine will therefore move forward, hence the friction acts backwards. You understand? But the wheel that is controlled by engine, in order to produce this forward motion, it needs to rotate in this direction. Can you see that? So in order for you to rotate that direction, the frictional force is in this direction instead. Yeah? Okay? So these are the slightly trickier ones that you need to take note of. So once you draw your free body diagram, that's where we are able to make use of the formula F net equals to NA. But even before we can do that, we have to understand that when they say an object is at equilibrium, hello, Sec 3? Okay. Do you have the notes? Sorry? Do you have the notes? Yes. How many? Free sitting, so you guys can find. Is there any more seats? Are there any more seats? Let me get a chair corner. You guys should really everyone see. Where do you want can squeeze more. I like so many six. Okay, so let's review. Once you have drawn your free body diagram, the next thing to take note of is when the presence of a net force. So like we have seen earlier on, if let's say they say the body is at equilibrium, by right you should know there is no net force or no resultant force. Understand? But if let's say the body is moving or there is a certain motion, then that means your net force is non-zero. Take note of that. Okay, then in dynamics, the next most important thing, especially for a structured question, is therefore the drawing of a scaled vector diagram, or in short, the presence of your, actually just vector diagram. There's no way of saying it. So vector diagrams is very important. You need to know how to draw your vector diagram, which also meant that in your physics exam, right, please bring your mathematical set along, okay? Because if you don't have a ruler, you don't have a protractor, you pretty much can't draw your vector diagrams. But for vector diagrams, there are two ways of doing it. The triangle method. Triangle method, right, we always use it if there is two or more forces. And this type of method, we would shift the diagram such that my lines form a closed loop. What do we mean by a closed loop? You realize that there will always be a start at a certain point, and then there will always be an end. That means it flows pretty nicely. It is not something like this where your forces just fan out. There's no origin, there's no end. Understand? So once you have forces that fan out like that, your job to do a triangle law is shift one of your force such that it forms a start and an end. Then your resultant force will be from start to end. Clear? Every time you draw a vector diagram, always give the scale. This is very, very important. The scale is determined by you, so don't make your life difficult by giving a very awkward scale, such that you have like 1 cm equals to 3.333, that kind of weird scale. Okay. Second, when you draw your resultant force, make sure it's represented by a double arrow. Yeah. Okay, if you're not comfortable with the triangle method, like most students are, because you don't know where to shift your force to, it's fine. You can also use the parallelogram method. But parallelogram method, right, the limitation is it can only be used for two forces. Okay, so something like this, yes, you can do the parallelogram method. But the moment you have more than two forces, you have no choice but to use what we call a triangle method, but a different version of it called the polygon method, where you shift the forces such that same concept, you have a start, you have an end. You understand? Okay. But most of your questions commonly tested are usually two forces. So just nice you can see use a parallelogram method. These you don't have to shift. You just got to copy the lines, then the resultant would be from where the force is, then goes up. So you can see that if your two forces are fanning outwards, your resultant is in this direction. But if your two forces are fanning inwards, then your resultant will be towards the inside as well. That's how you determine the direction. Understand? Okay, so let me show you guys an example of how do we do this. Let's say if the question say your object is at rest or at equilibrium, then you realize, right, for objects that are at rest or equilibrium, your lines will just keep on going in loops. There is no start, there is no end, it just keeps continuing. Can you see that? So this is when you know that your object is at rest at equilibrium because there's no resultant force. But if there is a resultant force, you realize that there is a free vector diagram that you can draw. For example, I have a point of interest here. My object is R. There are three forces acting on it. Fx due to pulley X, Fz due to pulley Z, and Fy due to pulley Y. Now, these are three forces. They want you to find the magnitude of Fx as well as the angle theta. So before you even draw the free body diagram and the scaled vector diagram and confuse yourself, ask yourself first, how do all these three forces work hand in hand to balance this entire thing? Because the question used the word here, supported. When the question says something like supported, balance, at equilibrium, this technically meant that your mass is at rest or at equilibrium. So by right, whatever forces is present, they balance each other out. So when you analyze this diagram, you take a look at the diagram first, then you realize Fx and Fz fan out. So Fx and Fz, right, will actually produce a resultant force in this direction here. Okay, this is the resultant force due to X and Z. Now, this resultant force is then balanced by Fy. That's why your whole object remains at rest. You understand? Okay, so you don't see three forces straight away. Your free body diagram need to have three forces. Then you are confused, like, how come the forces don't tally? Like, how come they don't match each other? You understand? Okay, this is because These two forces produce a resultant force upwards that is balanced by Fy. So now I want to find Fx. What do? I would first draw my Fz, or I can draw my horizontal or vertical first. So I have Fy. This is technically my resultant. Can you see that? Then my resultant is balanced by Fz in this direction. And then I can find Fy through my scaled vector diagram. Okay, understand? Okay, good. Obviously, just learning the theory is not enough. You'll be very confused if it's just theory-wise. So let's try to put whatever you have revised earlier on into working. Can we take a look at question 21 for a mock paper? I hope you guys didn't bring your mathematical set. If you never, you have to use aggregation. Actually, right, pro tip. If let's say you guys did not bring a mathematical set and you can't draw your angle, if the question did not say using a scaled vector diagram, then right, you can just draw a sketch and use your math. Remember math, you all learn sine rule, cosine rule in Trigo? Yeah, so that's the JC method. The JC method is we use math to solve for the angles and the length. Okay, that is the last resort. If the question did not say by using a scaled vector diagram. But if the question say by using a scaled vector diagram and you use math, then obviously you can't get the mark because you're not answering the question. Understand? Okay. But anyways, for those who do, can y'all try question 21 here? If you did not bring a protractor, it's fine. I want you guys to still draw a sketch of the vector diagram. I will give you the data later, but at least practice drawing the sketch first. Go through in 5 more minutes. 5 minutes. Yeah. Okay, can I go through this question? Now, this question is similar to the one that I went through previously. They say that there's a circus performer walking on a tightrope. At the point where she is standing, can you see they give you the hint here? Her body is at equilibrium. So that means, right, all forces balance for the, what's this thing called? Circus performer. Now, using a suitable scale, draw a labeled diagram to determine the magnitude of T1 and T2. Let's analyze this question first. You realize that, right, when you have tension force acting on the circus performer in these two directions, these two tension force will eventually produce a resultant force somewhere along this line, in this direction. Do you all agree? So this is the resultant force due to tension 1 and tension 2. Now, to keep the body at equilibrium or to keep the circus performer at equilibrium, this resultant force is balanced by, sorry, this circus performer is at equilibrium, correct? The two tension force produce a resultant force here. But if there is a resultant force, it is not at equilibrium. So what balances this resultant force? The weight, correct? So at the back of the head, you have to know that the weight is equivalent to the resultant forces due to the two tension. That's why you have a part B. Hence, determine the weight of the circus performer at the back. Understand? So first things first, how do we determine the magnitude of the resultant force? You have 400 for T1, T2 is 490. Then the angles is as such. Your free body diagram, your scaled diagram should look something like this. First things first, choose a good scale. 1 cm is to 50 Newton. Tension 1 is in this direction here, 400 Newtons. Then tension 2 makes an angle of what? With respect to the horizontal, 30 degrees. Understand? Then from there, draw tension 2, 490. So your resultant is upwards, 550, if you use your scale correctly. Yeah? Okay. So hopefully you guys managed to get a scaled force of 550. But if let's say you did not manage to draw this because of you didn't get your protractor, right? So you guys at least just draw a sketch out for this. Okay, so once you have found your resultant force to be 550, they say hence or otherwise determine the weight. The weight would be 550 Newton. Okay, because you understood that the resultant force is balanced by the weight. Now read the question very carefully. If the question says determine the mass of the circus performer, 550 you need to divide by 10 to get 55 kg. Yeah? Okay, so read questions carefully, always. Okay, once you are done, let's go back to our notes and look at the last part for dynamics. What happens when I have forces acting on an object that is free falling? Okay, everyone done, eh? Okay, good. Okay. Now, let's take a look at what happens when I have objects with forces acting at free fall. Sorry, what happens if I have an object falling at free falling? Now, a lot of students are very confused by the term free fall. I don't know how somehow you all feel that free fall means it is I don't know, not moving at. There's some weird interpretation of free falling. But for today, I want you guys to take note. Free falling, right, once and for all, is just falling due to gravity. Okay? What does falling due to gravity means? This means that for the entire object, the only net force acting on it is the weight of the object. That is what free falling means. Okay? So I repeat, free falling means falling due to gravity, and that means that the only force, the net force acting on an object is the only force present, which is the weight of the object. Clear? And because it is the weight of the object, this leads to the acceleration to be 10 meters per second square, a fixed value. So whenever the question say, oh, this object is free falling, they straight away meant acceleration is 10. They also straight away meant that the only force acting on it is the net force, and that's the weight. Yeah? So once you have object falling due to free fall, can you see that the acceleration is constant? So in the absence of air resistance, we all agree the velocity time graph has to be a straight line. Why? Because you also remember, what does gradient of a velocity time graph give you? Acceleration. And since due to free fall, acceleration is constant, you agree that my gradient has to be a constant throughout? That's why your gradient is fixed. Understand? So gradient of the graph here gives 10. Gradient equals acceleration equals 10. Clear? Now, next, what happens if I'm still falling due to free fall, but now I have air resistance present? Now, air resistance is very nasty. It likes to affect a lot of things. So if, let's say, right, I have air resistance acting on it. Now, my object no longer, okay, previously, my object only have one force acting on it. That's the weight. But now, because of air resistance, my object has two forces acting on it, the weight as well as the air resistance. Okay? So as such, beforehand, my F net was equivalent to my weight. But now, my F net is equivalent to my weight minus my air resistance. Understand? Previously, without air resistance, my acceleration is constant. Why? Because my weight is constant. But now, because of air resistance, acceleration is not constant. Why is it not constant? Because air resistance is always increasing. This thing here is increasing. And as air resistance increase, your net force decrease. That's why your acceleration decreases. Understand? To prove that, look at the graph. Do you realize the gradient of the graph decreases? Get it? Okay. Now, before we move on, can someone tell me what affects air resistance? How is it that my air resistance is increasing? Sorry? Okay, but if it's air resistance, that means it's in air. Let's say it's falling from air. What affects air resistance? Velocity, correct. So air resistance is affected by velocity, which means if your object is not moving, there is no air resistance. Can you see that? Only when your object starts to move, air resistance is present. That's why at the beginning, when your object just started to move, it moved from not moving to starting to move, there was no air resistance. But then as it starts to accelerate downwards, that means there's velocity, right? Velocity increases. So therefore, my air resistance increases. Then as it keeps continuing moving, your air resistance increases. Yeah? So always remember this, air resistance is directly proportional to your velocity. Velocity increase, air resistance increase. Yeah? Then air resistance increase, net force decrease. Net force decrease, acceleration decrease. But because my acceleration is still present, because it's an acceleration, my speed still increases, just slower. I repeat, my acceleration decrease is not the same as deceleration. Deceleration means my acceleration, there's no acceleration at all. I'm slowing down. But when I say acceleration decrease, means I'm still moving faster, but now I'm moving faster, slower. Therefore, my speed still increases, but it increases to a slower rate. Okay, I know it's very confusing, but I'm going to write here again. Decreasing acceleration is not the same as deceleration. Decreasing acceleration means I'm still increasing velocity, but slower. Okay, but deceleration is your negative acceleration. This means I am decreasing my velocity. So when you write your reasoning, always be careful with the words you use. If you write acceleration, you meant that the object is moving faster. If you write deceleration or negative acceleration, you meant that the object is slowing down. Understand? But if my object is like this case here, still increasing in speed, just slower, this is decreasing acceleration. Understand? Okay. So then you realize something as well. How does air resistance affect your graph? As long as there is no air resistance, all your graphs straight line. That's the hint to tell you that air resistance is negligible. If there is air resistance, your graph is a curve. Okay? So this is good for questions where they ask, oh, using the figure, explain whether air resistance is significant or not. Then you just say, oh, the graph is not a straight line. Therefore, implying that air resistance is present. things like that. Okay, which then brings us to the last part, terminal velocity. How do object achieve terminal velocity? Once you know all of these content, that's where we take a look at. First step, when your object falls, what happens? At the very start, right, you must see, let's say this is the building, okay? Then my object, my ball is here. Now it's going to drop. So here. Now at position 1, okay, when it just starts to fall, to explain terminal velocity, this is what you do. At position 1, when it first starts to fall, there is only weight acting on the object because the object's weight is pulling it down. So F net equals to my weight. Therefore, F weight equals to MA. Now, what is weight? Weight is mg. Mg equals to MA. Therefore, acceleration is gravity, which is 10 meters per second. Okay, this is at the start. So there is an acceleration. What does that mean? Velocity starts to increase. Okay. So as velocity increase, the ball starts to move faster downwards. Now, then at position 2, midway when it is falling, because velocity increases, what happens? We learn that air resistance is directly proportional to velocity. Air resistance increase. So therefore, at this point here, I have maybe just like a little bit of air resistance present. Okay. So now what's my new F net? My F net is, because my object is still falling down, weight is still larger than air resistance. So F net is equals to weight minus air resistance. Understand? Now, since my weight minus air resistance is F net, we therefore say this is equals to MA. So overall, as my net force decreases, my acceleration decreases. I repeat, acceleration decrease, velocity still increases, but slower. Okay. Then finally, because my velocity is still increasing, I continue the motion here. Therefore, my air resistance increases. Okay. So at position 3 now, since velocity still increases, air resistance also increase up to the point where now air resistance equals to weight. Then from there, what's my F net? Because they cancel each other out, 0. Therefore, no acceleration. And therefore, constant velocity. Okay? Until it hits the ground. So that's how we used to explain terminal velocity. Now, will there be a case whereby my air resistance increased to be greater than my weight? Never. You don't see someone, jump from the building and suddenly halfway start to float up. It's kind of scary. Okay? Okay, so if you prefer a worded version of this, if you are the kind that memorize word for word, right? Explain the motion of the parachutist. This is what is going on here. Okay? But personally, I don't really like to memorize stuff. That's why you guys take physics, right? Because you don't really like memorizing stuff. So physics, nothing to memorize. And a lot of the time is understanding, then using the formulas to help you answer questions. Understand? Okay? Okay, good. So once you guys are done with this, can we take a look at the mock exam question? I think it's question 23 if I'm not wrong. Yeah, question 23. This question here. The weather balloon question. Can you all now try this question? I'll go through in a while. We'll try in 5 more minutes. Yeah. Alex, I flashed you the QR code. You just scan the QR code for the notes. Is it me or is it very warm here? Do you feel warm? Because all of you are breathing out carbon dioxide. Maybe you'll like take 5 minutes and not breathe for a moment. Let that aircon. Okay, can I go through these questions? Now let's take a look at this question here. The figure shows a weather balloon immediately after takeoff. So for this question here, they say the weather balloon is immediately after takeoff. The balloon is drifting upwards, so there is a sort of like a net force upwards. The balloon experienced an upward force 50 Newton. The weight of the balloon is 20 Newton. Gravity is 10. Now, if they say that the balloon is drifting upwards, you know for sure that your F net is in this direction here. And F net always determine your accelerations. So acceleration is always upwards as well. Okay. First question, determine the mass of the balloon. Now, how do we determine the mass of the balloon? We have the weight of the balloon given to be 20. To determine mass, you just got to divide by 10 because W equals to mg, 2.0 kg. Make sure you check your SI unit, your significant figures. Okay, because 2 sig fig is the least sig fig here, so you need to put 2.0. If you put 2, your school will minus 1 mark due to gravitation. Yeah? Okay. Now the next one, calculate the initial vertical acceleration. Acceleration can only be calculated by the presence of a net force. So what is the net force acting on the object? 50 minus 20. How do I know it's 50 minus 20 and not 20 minus 50? Because the question said the balloon is drifting upwards. So I know my net force is upwards. So 50 would be greater than 20. Then F net equals to MA divided by the mass. You get 15 meters per second squared. Okay. So your balloon has an acceleration acting. Your balloon has an acceleration acting upwards. That means it will have a velocity. Velocity is increasing. That's why the second part says the upward force now remains at 50, but air resistance increases to 40. So can you see that because it's moving upwards, guys, where would the air resistance be acting on? Downwards. It's not always upwards. So air resistance is acting downwards here. Air resistance is 40 newtons. So they want you to describe and explain. So how does this work? Now my object is moving upwards, correct? What happens in the presence of air resistance? Let me just change color first. Okay, what happens at the presence of air resistance? Now my net force is acting downwards, correct? Now my net force is acting downwards. My acceleration is therefore acting downwards. What was my original velocity, guys? Upwards. Because velocity and acceleration in opposite direction, therefore my object will be slowing down. Okay, so a lot of students tend to misconfuse this part. As long as I give a negative acceleration, they straight away say, oh, deceleration, object slows down. That's not the case. Whether your object speeds up or slows down depend on your direction of velocity and acceleration. I repeat, a negative acceleration we learned earlier on was supposedly known as a deceleration. Yes, but this is only if my acceleration and my velocity is in opposite direction, then I will slow down. Okay, if let's say I have a negative acceleration, when is it considered an acceleration? This is when my velocity and my acceleration is in the same direction. Then my object will speed up. Yes? Why the balloon don't what? Because it's still moving up. So the deceleration will slow it down until it reaches 0, then it will go down. So right, what happens to your balloon is it will rise up until it comes to a stop, then it will start to come down. Okay? So guys, can I repeat this part here? Negative acceleration does not mean deceleration. It only means deceleration because your velocity and your acceleration is in opposite direction. So if this is positive, then this would be negative. Then your object slows down. Negative acceleration can also mean acceleration if your velocity and your acceleration is in the same direction. Then this negative acceleration means speed up, so your object will increase in speed. Do you understand? Okay, it's a little bit confusing because of the direction, but it's very important to take note of that. Not everything negative means deceleration. Clear? Okay. The only reason why your school notes or your textbook says deceleration because by default they assume velocity to be positive. That's why everything negative, deceleration, slowing down and whatnot. Okay. Okay, so for this scenario, you can see my velocity is moving upwards because of air resistance. My acceleration now moves downwards. So hence, this is in opposite direction. Hence, object slows down. So when the question asks you to explain, you say balloon will now decelerate because of negative acceleration. Okay. As a result, net force becomes and then explain is because net force becomes negative due to your air resistance. No, this one is decelerate. Okay, once you guys are done, we take a look at the next note already. The next topic, turning effect of forces, moments. Let me just exit this first. Yeah, better. Okay, now let's take a look at moments for those who are done. Now, moments is a continuation or turning effect of forces, right? It's a continuation of your dynamics because it still talks about forces. The difference being dynamics, right? There wasn't a fixed point. That's why if I push, let's say my pen up, right? My force is upward, my pen moves upwards. If I push it down, it moves down. But when you come into turning effect of forces, you need the presence of a fixed point because you realize if I fix a certain point and I push it up, the force turns into a turning effect. You see that? That's why it's called turning effect of forces. As a result, it is also a vector quantity, which means to say there is two directions involved. So moments here, take note, is a vector quantity. Direction is required. What are the two directions for turning effect? Clockwise or anti-clockwise? Okay? I believe all of you guys should know how to find clockwise and anti-clockwise. If you don't know in the exam, just look up at the school clock. Okay, clockwise means 1, 2, 3, 4, 5, 6, 7, 8. So anti-clockwise is the opposite direction. If your school clock is digital, then bless you. Okay, clear? Okay, so under turning effect of forces, the most important principle that you need to know is the principle of moment that states that this phrase is important. If a body is in equilibrium, everyone can remember the second one. Sum of clockwise moment about pivot equals sum of anti-clockwise moment. But if you don't write this thing in your definition, they will not give you the mark. So you must say, when a body is at equilibrium, the sum of the clockwise moment about a pivot or point equal to the sum of anti-clockwise moment about the same pivot. As a result, we can therefore use the moment equation here, F times D, to say F1 D1 equals F2 D2. Okay? So most of the time when we want to answer a moment question, we always have to tell them first by using principle of moment. In your exam, I already given you a calculation template here. By right, this one is very foolproof. This is what you should write down in your exam if it's a moment question. Word for word, you cannot just straight away write F1, D1, F2, D2. Some of you guys even better, don't even write this F1, D1, just write numbers like primary school like that. Then after that, therefore D2 equals to D. Don't, because now in physics, you need to have a presentation. So they will give you marks for presentation. You have to say taking moments about, state the pivot where it is, then sum of clockwise equals sum of anti-clockwise. Then F times, then yada yada, all the forces that is present. Understand? Okay, the first two phrases is very important. So that's a moment question. Now, take note. When they also mention when a body is in equilibrium, they will sometimes ask you, what are the two conditions needed to be fulfilled for a body to be in equilibrium? Take note, number one, resultant force must be zero. If your object is at equilibrium, that means, what does this mean? Any upward forces will add up to be equal to any downward forces. That's what they meant for translational equilibrium. Resultant forces is equal to zero. And it also means any leftward forces is equivalent to any rightward forces. Okay. Next, the second condition is if let's say my object does not move up, down, left, and right, but is rotating at the spot, it is not at equilibrium. Okay, because resultant moment needs to be zero in order for it to be at equilibrium. So that means any anti-clockwise moment is equals to any clockwise moment. Which means in the exam, to solve for a body at equilibrium, usually we start off with the moments first. Then to solve for other forces, we can make use of this relationship above. Okay, let me give you guys an example. An example is something like that, where they don't give you a pivot, they give you two forces unknown that they require you to find. So let's say they say, find the force A and force B. These two are tension forces, tension A, tension B. How do we usually solve questions like that? We will put one point here to be a pivot. So let's say for this question, I put A to be a pivot. Now remember, in a moments question, any forces passing through your pivot, automatically no moment. I repeat, Any forces that pass through your pivot, no moments at all. That means they won't create a turning effect. So if tension A is passing through pivot, there is no moment by tension A. I can then calculate tension B. This is anti-clockwise moment. Then due to the weight here, clockwise, due to the weight here, clockwise. So I just have to add up. So anti-clockwise moment equals to the clockwise moment. I can calculate tension B. Then to calculate tension, so that's me using this second condition. Then to calculate tension A, what do? I use the first condition. All the upward forces equals to the downward force. So I just take downward forces minus tension B, I'll get tension A. Understand? Okay. If you want to make your life difficult, you can put pivot at B, then do the same thing to find for A. But that will be a longer way. So the faster way is still upward force equals downward force. Okay, understand? Any question? No? Okay, good. Can we take a look at the mock paper questions 24? Can you guys try this question? Remember, locating your pivot is very, very important. Can I get a common answer from you guys? Your school requires you guys to put at least 6 feet or 3 SM? At least 6 feet? Did your teacher mention? At least 6 feet? Okay. 3 SF. So I think, right, the thing is, some schools say 3 SF, some schools say at least 6 feet. But from what I understand is, right, if let's say you decide to do least 6 feet, make sure your entire paper you do least 6 feet. If you decide to do 3 SF, the entire paper do 3 SF. At least consistency. Understand? Don't some questions do least 6 feet, some questions do 3 SF. Then they will deduct the presentation mark on your side. Okay? Okay. I'll go through in 5 more minutes. Huh? Okay, can I go through this question? Now, take a look at this question here. The figure shows a simplified diagram of a paper hole puncher. A force of 6 Newton is applied vertically downwards to punch a hole on a piece of paper, but friction acts on the knife and cannot move downwards, even if the 6.0 Newton is continuously applied. So there's a frictional force here. The lever has a weight of 1.0 Newton. Weight of the knife is negligible. Now, every time you have a moment question, right, I want you guys to read the question carefully, because for this particular question, they were nice enough to give you the weight of the lever. In some questions, they don't. They just gave you the mass. Then your job is to locate where the weight is and then make sure you always draw it at the center, especially when they say it's a uniform beam or uniform object. You understand? Okay, so read through the question very carefully and don't miss out on any additional forces that was meant to be there. Yeah? A common thing that they like to do is they don't draw the weight for you in the question. Your job is to find out, is there existing weight? Okay? So first one, state principle of moments. This one I don't have to go through. It's already inside your notes. Just make sure you include the word body in equilibrium. Understand? Okay. Now the next one, by using principle of moment, calculate the friction. Can someone tell me where is the pivot here? Or where would you put the pivot to be?
The hinge.
At the hinge. How do I know which position to put a pivot? Always ask yourself, if I move this object, where is a fixed point that doesn't move? So if you move this lever up and down, right, you realize the hinge is fixed. So this is where the pivot is. So the 6 Newton will create a clockwise moment about the pivot. The weight will also create a clockwise moment about the pivot. Then your friction will create an anti-clockwise moment about the pivot. Understand? So from there, by principle of moment, by right, this answer key, can you, if you guys did not write, make sure you write this. Taking moment about the hinge. This is important. Huh? Then from there, sum of clockwise moment equals sum of anti-clockwise. Then what is my clockwise moment? What did they call the 6? They didn't call it anything. 6.0 times distance plus weight times distance of weight equals to distance of friction times friction. 33.7, or if you do list 6 weeks, 34. If both sides is meters, yes. Any left-hand side meters, right-hand side has to be meters. If you don't want to convert to meter, make sure you use cm throughout. But when you're calculating moment alone, moment force times distance, have to convert to meter. When you're using principle of moments, because both sides, the units are the same, they cancel each other, it doesn't matter cm or meter. Understand? But when you're calculating moments alone, it needs to be meter, SI unit. But if in doubt, just put everything to SI unit. Okay? Okay, the next part. State and explain 2 things you need to answer. State first, then explain whether the moment due to the 6.0 Newton force will increase, decrease, or remains the same when the lever of the hole puncher is pushed down. So, what is the moment due to this 6.0 Newton? This 6.0 Newton's moment as of now is force times the perpendicular distance of this one here. Can you see that when you push it down, even though your 6.0 remains constant, your horizontal distance will start to increase. Okay, to be increased to be what? To be the length of the lever. Okay, so as a result, the length perpendicular distance starts to increase, your moment will therefore increase, even though your force remains the same.
That's like my increase past correct, but then I never speak the perpendicular distance right in our mind.
Yes. Okay, done. Can I move on to the next part of your notes? Okay, now let's move on to the next part of the notes here, which is your stability. Center of gravity, right, basically is the point at which your entire weight seems to act on. But technically in physics, what does this mean? As long as they give you a center of gravity, always draw your weight there. That will be where your weight is for. But a lot of students tend to be very confused, not say confused, but you understand stability, but somehow you don't understand it. What I meant is, right, how does stability works? First things first, when we talk about stability in an object, there are three types of equilibrium they can be at: stable equilibrium, unstable equilibrium, and neutral. Now, maybe drawing the diagram will better help you guys understand. When I have a stable equilibrium, right, what does that mean, or why am I stable? It's usually because, let's say this is my cone, and then I have my cone in this direction. So the weight of my cone is downward acting in this direction here. And if let's say I were to displace my cone, I shift it towards the right. Can you see that this is the pivot? Okay. What happens when I shift my cones to the right? My weight or my center of gravity will also shift towards the right. Correct? Tilt it slightly towards the right because I'm tilting my cone. But because the new center of gravity, right, still lies within the base area, it will create a anti-clockwise moment about the pivot to bring my cone down. And that's the reason why I'm stable. Do you understand? But if let's say I'm unstable, same thing. I can draw a diagram to show you. Unstable equilibrium, right? Let's say my cone is in this kind of position. Okay. Now, for now, my weight acts along the pivot, so it's seemingly stable. But what happens when I displace it slightly? When I displace it slightly to the right, my weight will now shift slightly more towards the right. Then as a result, can you see that this will cause a clockwise moment, continuing the motion, causing your cone to topple? That's why it's unstable. Understand? So I know your textbook, right, what lie within the base area, lie outside the base area. That part can be very confusing because what has the base area got to do with stability? The reason is because of this. Because if I lie within the base area, I can create a moment to restore equilibrium. So if I'm pushing it upwards, the moment created, bring it back down. But if I'm lying outside of the base area, the moment created will continue the toppling motion. That's why I will topple down in this direction. Do you understand? If I am at neutral equilibrium, what does this mean? This one was pretty straightforward because right now my pivot is the entire plane here. So let's say my cone is resting. My pivot is this entire region. So no matter how I push my cone, my weight is still within the pivot. That's why I don't have any moment created to topple it or displace it. Yeah? Okay, so that's the explanation that we do for stability. That's why for the answering technique wise, we will always say, okay, the center of gravity or the line of action of the weight lies either within, outside, or there's only two options, within or outside the base area, producing a certain moment about the pivot, causing the cone to topple, cone to restore equilibrium, yada yada. Whatever the question wants. Understand? Yeah. Why does it work? Because you see, my center of gravity originally was here at the pivot, right? So it's sort of like not moving. Then what happens if I displace it? My center of gravity will shift because my cone shift also. Alright. So the center of gravity shift there here. Can you see my pivot is here? Then I will create a clockwise moment. Then this clockwise will cause it to topple.
So there's no moment.
There's a moment, the clockwise moment, that cause it to topple. So the cone was like that. Center of gravity is at the pivot. All right, my center of gravity is that. Then what happens when I displace it? You see the center of gravity is now outside of the pivot. Then it creates a turning effect to topple it. Get it? Okay, so what are the factors that affect stability? Just take note, if you want to increase stability, if you're unstable, you lower the center of gravity or you increase the base area. That's why all Formula One cars are very wide, because they need to be stable. See, physics and F1 is close to linked. Okay, clear? Do you know that there's a racing car race, right? Whereby, right, they really play along with these, but it's not F1. It's a kind of race where there is two drivers. One steal the car, the other one, right, is beside the other. It's like in a I can't remember what's the name of that race, but the other driver will be sitting beside, right? And that during the entire race, right, that driver will be just shifting his body weight to maneuver the car. There's such a race, you know. It's quite interesting, but it's quite funny when you watch it, because you will see the two of them just moving in sync with each other. Okay, clear? Okay, good. Can we take a look at one MCQ question for this mock question? Your MCQ question 8. Okay, guys, try MCQ question 8. Okay. What's your answer for this one here? Guys, what are your answers for this one? D, A, anyone else? Is there a C? Is there a B? The guys at the back, what's the answer? D. The answer is D. Why? Because, right, whenever it is suspended, make sure the line of pivot has to line together with your string. Understand? So the difference between A and D is this. It's a very minor difference. But if you draw the line down for A, you realize that it is not along the pivot. Can you see that? But if you draw the one for D, you realize that it's along the pivot. Yeah? Okay, it's a very minor difference. Okay, good. So that is for question 8. Now the next one, question 7. Can you guys try question 7? Okay, what is the answer for this one? Who chose A? B? C? D. B. D. Answer is C. Okay, for this question here, which force will generate the greatest moment? Greatest moment, they gave you a fixed force. That means what? You need to find the longest perpendicular distance, correct? So longest perpendicular distance will only be C, because perpendicular, this is your longest perpendicular distance. Understand? Okay. A will not even have a pivot here. The perpendicular distance is this. B, the perpendicular distance is this, which is not long enough. Clear? Okay. Okay, good. Now we are done with this one. Can we go back to our notes? We look at the last topic for revision, pressure. Does anyone need a toilet break or something? Or a snack break? Yes? Okay, I give you guys a 5 minutes toilet break. Share cubicle if you need. Because there's only 5 minutes. You all know where the toilet is? Just go out of this place, then you will see a tuition center with a freaking huge sunflower. Just continue walking along that lane. Okay, so you go out of the center, then you turn left. For girls, right, if you all need the toilet, you need to take the key. So the key is behind the white cover, above the printer. Okay, can? Okay, go for your 5 minutes break.
Some explanation for example.
Yeah. Yep. You come here. Wait, you can come here. Why? I reply this one. You see a sunflower, you know, Kumon? Along the straight line all the way at the back. Yeah.
Some explanation about this before. Who's the question? What really is the question?
You shouldn't be need me to.
I need the. I don't really understand this question.
Okay, so basically, right, what happened here is that it says temperature rise of a piece of lead struck by an air gun lead pellet. So basically, your lead pellet here hits your lead target, right?
Yeah.
Then there's a galvanometer here to measure. Usually, galvanometer measures like voltage, most of the time voltage. Okay, so there's a thermocouple, hence the galvanometer, because thermocouple works based on voltage. Then there's a detector. So they give you all the parameters, right? Okay, determine the temperature rise of the lead target based on the deflection reading. So what's the deflection reading? 4 divisions. What is the galvanometer sensitivity? Every 5 division, 1 degree Celsius. So 4 division will be 0.8 degrees Celsius. Okay, understand this facts? See? Okay, so that means your lead, right, increase by 0.80 degrees Celsius. Calculate the energy gain by the lead. There is a temperature change, so therefore the formula will be Q equals to NC delta delta. So the mass of the lead, which is 35.5 divided by 1,000. Then your C, capacity of the lead, which is this one. Then times the temperature change, which is this one here. Right? That's why the temperature is this. So every time you got a temperature change, right, sure, we use Q equals to NC delta. Okay. Then now your lead gains energy because it hits the target. Then they say the lead target better x with 5 degrees. Your lead target is 35. Or to catch and immerse into a mixture of ice and ice. So remember, this was a temperature gain by the lead target, right? This temperature gain, if I immerse it in ice and water, what happens to the energy gain?
in the
I have certain energy gain here, then I invest into something cold. What happens to this energy gain?
decrease.
It will lose to the ice and water. So it becomes a heat gain, heat loss question. So energy gained by ice and water equals to energy lost by that constant. Understand? But your ice and water is very sensitive because ice need to become water. So energy gained by ice, Q equals to NLF. Then after that becomes MC plus MC then because I change surface, then water change temperature. Then plus water changes your 100 animals. Then these equals to ready? Yeah. Okay. And then the two assumptions usually no heat loss is the capacity of the container is because you assume that it didn't absorb heat, but containers they do absorb heat as well. You understand? Okay. Then for the one who asked me, I would say, okay, why doesn't the balloon go down straight, right? It's because can you see that even though your net force is but your balloon was still moving upward. So imagine your balloon, right, is moving upward at a velocity of 3. And now the net force is downward. It doesn't straight away just pop go down. It will go up, and then this downward force will cause it to do something lesser. Maybe you can go first. Okay, so it's not immediate down because the net force can cause immediately probably to decelerate. But your decelerate will cause you to go 0 first, then you go yeah, so you will have a net force down. Correct? But it will still moving up. So imagine you're moving up, and now come back to you. Okay, you don't show it go down. Come back to you, you move up until you slow down to 0. That can mean you become go down. Unless at the point that the net force is down, already below, then you can go. Okay?
Okay.
Okay, the one back, not yet. The one who wants me to explain question 7. For question 7, right? Basically, they wanted you to find out which creates the greatest moment you have not. Yeah. So greatest moment, since the force is already fixed at 40 degrees, the greatest moment can only be found by the largest perpendicular distance. So the pivot is here. This force, right, perpendicular distance is actually from here to here, 90 degrees. This force perpendicular distance is from here to here. So this force perpendicular distance is from here to here, perpendicular distance, and then this force perpendicular distance is from here to here. So you can see that, right? As long as you want a largest perpendicular distance, always make it 90 degrees. Any other angle, right, will all not be the largest distance. Okay. Do your 10 years series. Do your 10 years series. Topical.
Because every time I like revise, I have that more section. But I come to my 10-year series, right? It's like signing my day.
That's why I won't do your 10 years series. Because not enough practice. Because physics is like math. You cannot just remember the content and go for exam. Yeah, how you study for math is how you study for physics. So how you study for math? You practice, right? You can memorize the formula, but you go for exam, you look at the question, like how to start. So you do your 10 year series, that's the basic, because that's supposedly the easiest. Then you look at what kind of assessment topical questions. But the 10 year series usually is a good training ground. Then if let's say you don't know how to do, you refer to the answer key. Then you see how they do, then you close it and then you redo your question. Yeah, so you don't just look at the answer key and like, okay, I'm done. I know how to do it already. You read through the answer key first, understand, close it, then you don't redo the question. Yeah. Okay, physics is a lot of practice. Can never just read then go for exam. Bio maybe can, because yeah, but physics and chem can. It's for your own snack. What's that? Oh, it's cookie. It looks like nugget. Okay, everyone back. Back and fat. Okay. No, not FAT, FED. Why would you become fat by going to the toilet? Okay, anyways, let's take a look at the next topic, pressure. I presume everyone has already covered pressure in school. Yes, correct. Okay, now let's take a look at pressure. For pressure, right, to study this topic, right, it's very straightforward. Just study it according to are you talking about pressure of a solid or are you talking about pressure of a fluid? Because there's a difference in the formula involved. Okay, number one, when we take a look at pressure, right, by default definition was force exerted per unit area, correct? But this definition only allow you to use it when you're describing for a solid. So most of the time, right, when you have a solid object, there is a certain weight exerted by the solid over a specific area. So that's why you use force over area. But because most of the time the question gives you weight instead of force, a lot of students get stuck. So we can also say pressure is equal to the weight exerted per unit area. Understand? But if it's a fluid, now what's a fluid? Fluid is not just liquid. Fluid comes from the name anything that flows. So fluids is liquid and gases. So as long as it's liquid or gas, you want to calculate the pressure, you use the formula rho GH. Understand? But rho GH only works if you are calculating the pressure of the specific fluid on top. If my fluid above is open, exposed to air, don't forget to add the atmospheric pressure. Okay, now by default on Earth, our atmospheric pressure is taken to be this. Now take note, pressure has three ways of representing it. Number one, I can represent pressure based on Pascal. So on Earth, atmospheric pressure is 1.01 times 10 to the power 5 Pascal. I can express pressure as 76 centimeter Hg. The Hg is a chemistry symbol for mercury. So therefore, if my liquid used was mercury, the height obtained will be 76 cm. Question, how do we convert from this unit to this unit? Anybody know? How do we convert 76 cm Hg to Pascal? We use pressure equals to H rho G. You understand? Whereby my H here, I put 76 divided by 100, change it to meter. The density will be the density for mercury, 13,600. then the G here would be 10. That's how I convert it into atmospheric pressure. Yeah? Lastly, which is less commonly expressed, we can express atmospheric pressure as 1 atm, which means, just remember, 1 atm is equivalent to 1.01 times 10 to the power of 5 Pascal. Get it? Okay, so before we move on, question is, how do we measure atmospheric pressure? What instrument do we use to measure atmospheric pressure? Nano or baro? Barometer, not manometer. So atmospheric pressure can only be measured by a barometer, which means to say, if I were to use a barometer in the exam, I am straight away calculating or measuring the pressure of the atmosphere. Don't say I'm measuring pressure of an unknown gas or something. Clear? Okay, so let's take a look at how does the barometer works first. Once you guys are done, turn to the next page. Now, by default, your barometer has a few parameters. Number one, there is a mercury inside here. Then there is vacuum. Take note, in your barometer, the pressure of that gap on top is equals to 0. Which is why when my atmosphere exerts a pressure on my mercury, it pushes the mercury up, giving you a height of 76 cm. Understand? If let's say this device was left on this classroom, but then suddenly the height was much lower, not 76, what could be the possible reason? If H is less than 760 millimeters, what could be the possible reason? What? But I left it in this classroom. But this classroom, did the atmosphere of this classroom change? No, because you can't change Earth atmosphere, correct? So why is there a lower height? Probably because this part here, vacuum space, filled with air. Understand? That's the only possible reason. Instead of vacuum, there was a little amount of air inside. That air exerted a pressure, pushing the height down. Yeah? Okay, so always remember, you cannot change your environment atmosphere. It is fixed. If you want to change the height of this, two ways, either introduce air in here or carry this entire device to another planet. Understand? Okay. Or some say the top of a mountain, because mountain's pressure is slightly lower than Earth's pressure. Get it? Okay. So that's a mercury barometer. Now, the next thing, what happens when they do a few changes to your mercury barometer? Let's say I add more mercury. Does this affect my height here if I add more mercury? Remember, the barometer measures the atmospheric pressure. If I add more mercury into the pool, does this change atmospheric pressure? No. So what happens is your height remains constant. You understand? So even if I have a large reservoir or a small reservoir, my height still remains at 76. Clear? Next, if I tilt the glass tube, does this change your Earth's atmosphere? No. So therefore, even though I tilt the glass tube, perpendicular height still remains unchanged, still becomes 76 centimeter. Do you understand? Okay. Next, what happens if I push the glass tube deeper in? Pushing the glass tube deeper in, do I change Earth's atmosphere? No as well. That's why height of mercury column will not change. Okay. Now, what happens now if I introduce water into the space? Now, does water carry a pressure? Yes, although my Earth's atmosphere don't change, but because water's like air carries a pressure on top here, it will push down against your mercury. That's why your mercury height column will decrease. Do you understand? Okay. Lastly, what happens if there is a crack in the glass? By right, it was filled with vacuum. A crack in the glass will introduce air. So even though you did not change Earth atmospheric pressure, you introduce air into the vacuum, so your height of your mercury will decrease. Get it? So to answer a barometer question, you always have to ask yourself, did I change Earth atmosphere? If I did not, my height stays the same. But if the change caused the vacuum on top to be gone, then yes, my height will change as well. Get it? Okay, now the next part, after we measured mercury barometer, we now can take a look at a manometer. What does a manometer measure? Pressure of any gas, correct. So manometer measures pressure of gas. Any gas that you want, you can now attach it to a U-shaped manometer. Now, how does a manometer work? It is always like that. Listen carefully. Wherever you connect the gas supply to be, it will exert a pressure of gas here. Understand? Now, manometer works based on this concept, same height, same pressure. So therefore, if the pressure of gas is here, same height, the pressure of gas is also here. Get it? Then from there, you ask yourself, what is this pressure of gas made up of? It is made up of the column, so H rho G, plus it is made up of atmospheric pressure on top, pressure ATM. So that's how we find out the pressure of a gas. Okay, always make use of the principle, same height, same pressure. I repeat, pressure of gas, because it's connected here, pressure of gas is measured here. Same height, same pressure, so the pressure of gas is also here. What is it made up of? The column above, H rho G, plus atmospheric pressure, PATM. Get it? That's why pressure of gas is equals to atmospheric pressure plus the pressure of the mercury column. Easy? Okay, then finally, they make use of all these principles and use it in an application called hydraulic system. So hydraulic system is a system that makes use of pressure so that you don't have to exert a lot of force to carry a heavy load. Okay, why is that so? Because in a hydraulic system, the pressure here and the pressure here is same throughout. So take note, for a hydraulic system, same pressure throughout. Can anyone tell me why is it that there is same pressure throughout inside a hydraulic system? Does anybody know why is it that pressure here equals pressure here for a hydraulic system?
P1 times A1 equals to G3 times A2.
That is the formula because we say it's same pressure. But the question is, explain why is the pressure same? Because what?
First one equals first one is
Same thing as the formula as well. Liquid is incompressible. Because you cannot change your liquid's what's that called? Space. You can't squeeze your liquid. The force that you exert remains constant. You understand? So same pressure throughout is because liquid is incompressible. That's the reason why, and that's how a hydraulic system works. Which means if you were to change this entire thing here to be gas, you use air instead of liquid, your hydraulic system won't work because air can be compressed. Understand? Okay. So once you understood that pressure is the same throughout, what's the formula for pressure? Force over distance. So therefore, for this diagram, force 1 over area 1 equals force 2 over area 2. That's one formula I can use. Okay. The next formula I can use as well is volume, because volume is matter. You learn in primary school, matter is has a fixed, if liquid have a fixed volume, they can't change. So what is volume here? Area times distance. So sorry, area times distance, correct. A1H1 equals A2H2. Okay. Then lastly, you can also make use of the principle, work done is the same, because how much energy you use to compress will be transferred to how much energy is used to bring it up. So therefore, force 1 times distance 1, force 2 times distance 2. Take note, the distance here is your parallel distance, not your perpendicular distance. You understand? Okay, good. So can we take a look at your structured question, question 25? Can you guys try question 25? I'll go through in 3 more minutes. Huh? Okay, can we go through this question, guys? Now, read the question carefully. 2 identical barometer A and B are set up at sea level next to each other. The space above the mercury is a vacuum. The question here gave you barometer, so this measures atmospheric pressure. Then check, they say that the space above mercury A is vacuum. So this is vacuum, this may or may not be vacuum. Both of them measures atmospheric pressure. First question, state the atmospheric pressure measured by barometer A. What is your answer for this, guys? 76, correct. How do we get 76 cmHg? 1 meter minus 0.24. Yeah? Okay, the next one, determine the pressure at point P. So remember, pressure in a fluid here, always ask yourself what is above it. Above P is your column here, but is there any atmospheric pressure here, guys? No. The pressure here is vacuum, so 0 Pascal. So therefore, the pressure at point P is whatever is above here. Therefore, H rho G, and hence substitute my H to be this column here only, which is 1 meter minus 24 minus 30 cm times the density of mercury times 10. Understand, guys? Every time you have a fluid pressure, always ask yourself what is above it. What am I carrying above? That would be my pressure. Yeah? Okay, the next question. Suggest a reason why the space in B is bigger than the space in A. I literally gave you guys the answer just now. Because there is air trapped above the mercury column in barometer B. Okay? Okay, the next part. If the diameter of barometer A is double, explain any change to the height in the mercury column. Question. Does doubling the diameter of your column changes atmospheric pressure? No. So what happens to the vertical height? Yes. But they want you to explain. So if you just say it remains unchanged, you're not explaining, you're just stating. So the explanation comes in the second part because the vertical height is dependent on the atmospheric pressure. Nothing to do with the diameter. So even if you use like a very huge pipe, your height still remains the same, 76. Okay, hence okay, good. So we have done questions for all of these three. We have topics that we revised. We still have some time. Can we take a look at the remaining question in the mock paper? Can you all do the last question for this one here, which is the ray diagram question, question 27. Lenses. Manqi, you measure from here, wherever they say between compressed to the distance we measure. So the question would state what the particular distance is. So it's the same as this height. Yes. Pressure of mercury in the column is also equal to atmospheric pressure, provided that there's a vacuum on top one, there's no air. Yeah, correct. Subject is correct. Do the last question, question 27.
I might need to function because I need to travel to another overmount country.
For fresh course. Let's do fresh course today.
Or in my
Focus. Okay, go ahead, man.
It's another day. I think.
You haven't learned answers? Okay, then you just listen first.
Is it possible if I can do the feedback for this?
Can. I give you the QR code. Then you can take each step you can, or you can take it. Okay, it seems everyone is done. Can I go through this question? Now, for Lance's question, when you draw a diagram, right, it's always very straightforward. Your lines intersection tells you where the image is. I repeat, when your lines intersect, it tells you where the image is. For this question here, there is a thin converging lens, and then they say the path of one ray from is drawn from A to the lens to then where it is being drawn. They ask you to draw suitable ray from point B to locate the image. Now, let me explain how this is done. Maybe I use this one better. The image that is given to you is an arrow. It's a three-dimensional image. So this light ray, when it casted onto the lens, produces a bottom arrow at this position here, the bottom of the arrow there. Do you understand? Now they want you to draw light ray from B to find the image. How do we always draw light rays for lenses? The standard lines. Number one, I will need to draw a horizontal line that cuts through the center, the optical center of the lens. So there will always be a line that cuts through the center. Understand? So this is the line that I draw. The next line will always be parallel to the lens first. Okay. Then this will always cut through the focal point. But this question, did they tell you where's the focal point? No. So how do you know where your image will be? Yes, can you see that, right? They already gave you the hint where your image will be. So your image will definitely be here, just how tall or how short. Here. So your image will always be at any point in this line here. Therefore, you draw your line and extend to any point of that line. Yeah. And that's the reason why my image is found to be at this position here. You get the hint. iPad keeps jumping. Yeah. Understand? Okay. So I repeat. The question will always tell you where the image is. If they don't, they will give you a hint. Like for this question, if they don't give you the focal point, the hint given to you is the image is always here because the image is produced by the bottom of the arrow. That means, right, your image for your arrow will definitely be along this axis. Get it? So once you draw a parallel line, how do we locate the image? You just cut that axis. Clear? Then from there, you can find out your focal length is from here to here. Clear? Okay? What thing? Yes. Just that maybe computer can't do that. Okay. No. No. Plotted because it's virtual. Yeah. Okay, so next, the converging lens here may be used to form a virtual image. State where should the object be placed. Now, guys, at this side of the lens, is it a virtual or a real image? At this side of the lens, it's a real image. So when will a virtual image be formed? At the yeah, at the left side. So this is virtual. So therefore, we say the object must be placed. Oh, wait, different now. This is the image is virtual. The question is asking you state where your object should be placed. So where should you place your object to create a virtual image? Less than the focal length. Understand? Now, remember that table that you need to memorize? I don't memorize the table, I memorize the diagram. Later, I draw for you guys the diagram. It's easier to remember for that one. Let's see. Okay, Ken? Okay, guys, before we move on to the next question, can I just show you guys, there's this one diagram that I use to help me remember the entire chunk, right? At least part of most of it is that whenever I want to memorize the lens image, I will always draw this. So this is where my lens will be. Now, every lens diagram, right, there is at least 5 positions that I'm interested in. Before that, I draw my focal point first, and I draw 2 times my focal point. For you, you just draw this. This will make sense when you go through the topic. Okay. Now, what are the 5 positions that we are interested in? The 5 positions are below the focal point, on the focal point, in between the focal point, at the focal point, and beyond the focal point. Beyond 2 times the focal point. Okay. So you realize I will draw the same size for all of them because they are all your objects. So this is a different positioning. Position 1, position 2, position 3, position 4, position 5. So what are the image formed by these positions? Position 1 will always be formed at the back of the lens because it's a virtual image. So this will be the image of the position and the image of position 1. The size of the arrows matter because it tells you the image is upright, magnified, and virtual. That's why I never memorize the properties. I just draw the diagram. By looking at the size, I can remember. I can just straight away get the properties. Upright, virtual, and magnified. Okay. Then the next one, virtual because anything behind the lens is virtual. Anything here is real. Position 2 will always be beyond 2F. By right, position 2 don't exist. We just draw it for the sake of drawing because position 2 is at infinity. So the image here, properties will be what? Inverted, magnified, and real. Understand? Can you see the arrows are inverted? The arrows is much larger in size, magnified, and the object lies on the real side of the image. That's position 2. Now, position 3 will be beyond 2F, but smaller than position 2. So this is position 3. Same thing, properties, real, magnified, inverted. Okay? Object at position 4 is a special case that you need to remember. Any object that lies on 2 times the focal point, the image will also lie at 2 times the focal point, and the image size will be the same. So this is position 4. So number 4, inverted real but same size. Understand? Then lastly, position 5 beyond 2F, it will be in between F and 2F. Diminished, inverted, real. So I always draw this diagram for lengths. I don't memorize that table. The table is way too confusing already. Okay, so don't have to memorize the properties as well. Just look at the arrows. If my size of the arrow changes, just see is it magnified or diminished. If my arrow invert, if it's inverted, means it's inverted. If it's not, then it's upright. Clear? Then the last one is just remember, this side of the lens is virtual, this side of the lens is real. Okay?
What is inverted real same size that is diminished real
Inverted.
English? Yeah, number 5 is diminished real
Inverted.
inverted.
Yeah. Do you understand? Okay. So rather than memorizing the table, I'd rather you guys memorize this diagram. Easier to recall during the exam. Clear? Okay, so once you're done with that, take a look at the last question. If the top half of the converging lens is removed, will the image still be formed, guys? Why not? Why not? If the top part of the lens is covered, let's say I cover this part, will the image still be formed? Why? It will still be formed because light still pass through your lens, correct? So the image will still be formed as object can still be refracted by the bottom part of the lens. Understand? Yes, less intensity. Okay, can? Okay, once you guys are done, the last structured question, question 26. Yeah, the thermal question. Can you guys try that question? For those who have not yet done thermal in school, just leave it.
Is that because of the organization my drawing is
No problem. Wait, let me just know. Okay, everyone done? Now let's take a look at the question, last question here. Question 26. The figure shows the boiler of a coal-fired power station. Hot gas rises and energy is transferred to the water inside the metal pipes. Describe how energy passes through the metal pipe, warm up the water inside. Take note, for this question here, right, you first have to explain how the energy is passed through the metal pipe. For through the metal pipe, this is done by what? Conduction, convection, or radiation? Conduction, because you are colliding with the particles, correct? So what happens is that energy is transferred by conduction. Then you need to describe it by saying molecules at hot end vibrate faster and collide with neighboring particles. Then energy is transferred to your neighboring molecules. At the same time, take note, there is a keyword here that a lot of students will miss out. The word metal. Now, what is metal different from any other non-metal pipes? Yes, metal has the presence of free moving electrons. That's how you get your third mark. The free moving electrons also collide with the vibrating molecules, transferring energy, and it repeats until it eventually reaches the cold end.